Hey guys, this is Fozon, and in today's lesson, we're going to be discussing sorting algorithms. So our lesson objective is we're going to learn the standard algorithms for sorting, and then we're going to apply selection sort and insertion sort to the elements of an array or an array list. You'll do the array list part of this on your own, but I will show you how to do it with an array. So sorting is literally what it sounds like. The definition that I have here is that sorting algorithms allow the computer to systematically arrange a group of values based on a certain characteristic. In just more simpler terms, if you give it an integer array with values that are not in numerical order, what the sorting algorithm will do will sort it in numerical order. Two examples of sorting algorithms that we'll be utilizing in this video are going to be selection sort as well as insertion sort. Once we do recursion, which will be in another section, we'll also cover merge sort, but you will need to learn the recursion for that sorting algorithm. But just for this video, we're going to be doing two sorting algorithms, selection sort and insertion sort. So let's start off with selection sort. What the selection sort does is that it finds the smallest element in the series and then makes that the first number. If we're sorting an array, what it would do, it would make the smallest element within the array in position 0. It would put that in position 0. Then what it does is that it finds the second smallest number in the array and then makes that the second number or the second position, which will be position 1 in an array. And then it continues third smallest, and then that puts that in the third location or position 2, and it continues until all the numbers are sorted. Let me show you a visualization so that it makes more sense. So we have four numbers, 9, 7, 4, 5, and let's say that this is stored in an array so that we can sort it through our selection sort algorithm. So we have 9 at the first position, and we want to find the smallest value. So 9 is going to be the current smallest value. 7 is less than 9, so that's going to be the current smallest value. 4 is less than 7, so 4 is going to be the smallest value. 5 is greater than 4, so 4 still remains the smallest value. So what we're going to do is swap 4 and 9. And then 4 goes here, 9 goes here. The reason why we swap it is because we don't want to lose the value at position 0. We want to keep 9 within the array, so we simply just swap it. Now that 4 is sorted, this is going to be part of the sorted array, and then all the numbers to the right of it are going to be unsorted. So let's sort the next value. What value do we want at 7? What value do we want at the second position, position 1? Well, 7 is the smallest value currently. 9 is greater than 7, so it's not going to be the smallest value. 5 is less than 7, so 5 is going to be the smallest value. So 5 is going to swap places with 7. Now, one half of our array is sorted while the other half is not sorted. So now let's find a value for position 3. So 9 is going to be our current smallest value. Let's look at the next value. 7 is less than 9. So since 7 is less than 9, that's going to be our new smallest value. So 7 is the last element, so we're going to swap that with 9. So now we have 4, 5, 7, 9. We're left with one element, so it simply sorts that with respect to itself. Now insertion sort is a little bit different, because what it does is that rather than finding an element and then swapping it with positions, it simply inserts it into the correct location. The first element is sorted with respect to itself. The second element is sorted based on whether or not it should be inserted before or after the first element. And then what it does is that every round the array is split into a sorted array and an unsorted array. So the left side of the position that we're at currently is going to be a sorted array, and all the values to the right is going to be our unsorted array. And what it will do is that it will find the appropriate location by comparing it to the values to its left and then finding where it should insert. So let's look at an example. So what happens is that 9 gets sorted with respect to itself. So 9 is going to remain there. So we could say that at the first iteration, 9 is the only part of our sorted array, while 7, 4, and 5 are part of our unsorted array. Now let's insert 7. So 7 is the second value, and we want to insert it in the correct location. So we compare it to 9. Since 7 is less than 9, 7 will come before 9 and will be inserted right before 9. This is our new array. So since this is inserted into 9. Now we need to look at the next position. So since we were at the second position, or position 1, let's look at position 2. Now we need to find a location to put 4. So 4 is less than 9, so we can insert it in between 7 and 9. But let's keep going to find a more appropriate location. 4 is also less than 7, so we can insert it right before 7. And since 7 is the position 0, that means that there are no other elements. So 4 is actually the least amount, or the smallest number we have currently with the sorted array. So now 4, 7, 9 becomes our sorted array, while 5 becomes our unsorted array. Now we need to find an appropriate location to put or insert 5, reflecting on the name Insertion Sort. So 5 is less than 9, so we can insert it right before 9. But let's keep on going. 5 is less than 7, so we can also insert it right before 7. But let's keep on going just to see if we can find a much better location. 4 is less than 5. So 5 is not less than 4. So we can't insert it before 4. So we have to insert it in between 4 and 7. So we insert it in between 4 and 7. And since that was our final element, we have our insertion sort algorithm done, and we have our sorted array done through our insertion sort algorithm. Let's move on to the compiler and actually test out these sorting algorithms. So we're in the compiler, and I've already created a main method, a selection sort algorithm, an insertion sort algorithm, and a print array method that you should know how to do because it is simply a for each loop that traverses through an integer array. But anyway, that's not the point of this video. I'm sure that you got the gist of that. Our main goal is to sort the values within this integer array using selection sort or insertion sort. So let's do selection sort first. So this is the selection sort algorithm. Let's break it down. We're returning an integer array back to the user. To be more specific, it's a sorted integer array. And the arguments are your simple, regular, unsorted integer array. I'm assuming because I don't really know how it would be sorted. I mean, it could be sorted, but more likely you would use this algorithm on an unsorted list because, well, we're sorting the list. Anyway, the outer for loop, what it does is that it traverses through each position of the array in order to find the value that we should put at the I location, or position I. The integer min position, what it does is that it keeps track of the position of the number that we want to put at that location. We set it equal to I because it could already be at the correct location, meaning that in the value that we have at that position could really be the same if it was both a sorted list or an unsorted list. A good example would be trying to put this into a sorted list. So in that case, min position would always be I. What the inner for loop does is that it finds the smallest value within the array to the right of the I position. Recall that the elements to the left of position I are already sorted, so we set j equal to I plus 1. Finally, we swap the values if we find the smallest within the unsorted list, aka the right side. We store the integer in temp to ensure we don't lose the value when swapping. Again, this is a very important part of computational thinking. You can't just swap through two statements by interchanging the variables because you'll lose one of the values. So you store it temporarily in an integer and you set that to temp. You assign the value of temp into the array that you're inserting it to. And then you return the sorted array after the for loop executes after the selection sort algorithm is done. So let's test to see if this works. So I'm going to the main method and I have this integer array 17, 8, 30, 38, 19, and 11, and I'm going to remove this print statement that tells us that it's a selection sort algorithm, and then I'm going to remove this comment that tells us this comment declaration, and we have a print array call, and it's going to print out the integer array that we get, the sorted integer array that we get, after we call the selection sort method with the unsorted integer array. So let's see if it works. Let's run it. And as you can see, it sorts it 8, 11, 17, 19, 38. That is sorted based on their numerical order. So now let's do insertion sort. Insertion sort is a little bit tricky because rather than using a for loop both times, we're going to be using a while loop within a for loop. Here's the insertion sort algorithm. It returns an integer array, a sorted integer array. The outer for loop will allow us to access the position of the element of which we will be inserting onto or into the sorted list to the left of position I. We set I equal to 1 rather than 0 because the first element is inserted or sorted with respect to itself. Recall the value 9 within our array within the presentation. So it's sorted with respect to itself, and then we'll incrementally, or we'll be inserting the other values with respect to the values in the sorted array. So the first element is going to be considered our first sorted array, and then the rest of the values are going to be considered our unsorted array. And then after every iteration, the sorted array length increments by 1, whereas the unsorted array length decrements by 1. The key will be the value that we're inserting into the sorted part of the array. What the while loop does is that it finds the location or position to insert it by constantly updating or comparing the array values if the key value is less than the value that we are comparing it to. It will keep on going to the left or inserting it into the left until it finds a value less than the key value, or if the insertion is found to be at position 0, hence the j is less than or equal to 0 Boolean expression. This ensures us that we don't get any array index out of bounds error, and then it just tries to find a -1, -2, -3 array position. So that this Boolean expression prevents that. So this ensures that if we do come across the first element, it will be inserted as the first element, whereas this one finds whether or not sorry about that. That was my air freshener, if you heard that. But this will find whether or not if we are allowed to insert it at that location. The final statement over here is the actual insertion itself. And then finally, it returns the value, or returns the integer array. So let's see how this works. Or let's see if this works, because I just showed you how it works. So let me do that. And let me do that. And as you can see, it has the same integer, that it returns the same integer array as the selection sort, mainly because they're both sorting it in numerical order. I hope this video clears some things up about sorting algorithms, particularly with selection sort and insertion sort. This is the Java syntax, and I'll make sure to leave the Java code either in the description or within the course website. Thank you for watching.